So for this discussion, I'm going to somewhat quickly go over the basic concept of experimental design. And I say somewhat quickly because I think this is spelled out fairly well both in the textbook and in your lecture notes. So I'm just going to put a voice to those concepts, I suppose. Because statistics are used in the context of this class to tell us something about the world, we have to follow the rules of designing experiments in order to be able to interpret our statistics accurately. So the first step in getting in doing an experiment is following the scientific method. Once you've identified an area of interest to you, on the slides I give some examples. Perhaps you're interested in studying attention deficit hyperactivity disorder, or what makes one person attractive and another person less attractive, what is the basis of memory, whatever it is that you may be thinking of. The first step is to review the literature and find out what is already known. And once you do that, once you become more familiar with what we already know about a topic, pretty soon patterns start to emerge and you start to realize what is missing. Now, I like to think of doing research as completing a jigsaw puzzle, but without knowing what the picture is that you're trying to put together. So when you review the literature, you're basically looking at all of the pieces and kind of looking at patterns and colors and shapes and so on. And eventually you might find two shapes of a puzzle. One that might look like it fits inside another piece, like that. And so that's your hypothesis. A hypothesis is a tentative statement about the way the world works. And in the jigsaw puzzle metaphor, your tentative statement is, I think piece 1 and piece 2 fit together. Then when you conduct the actual experiment to test the hypothesis, you're essentially trying to put piece 1 and piece 2 together and see if your hypothesis works. Okay? So I give you a couple of examples on the slide. We're looking at slide number 14 right now. And if you go to the next slide, you see a few more specific descriptors of what a hypothesis is. A hypothesis should be based on observations or past research. That is, it's not just a wild guess. I think aliens built all of the houses in San Marcos. Well, there's really zero evidence that that ever happened. So that would not be a sound scientific hypothesis. A hypothesis should be as specific as possible, as much as your observations will allow you to claim. So just saying, I think that housing and aliens are related, that's not as specific as saying aliens visited us 100 years ago and built houses. So more specific is better. And then lastly, a hypothesis should be falsifiable. Falsifiable means that it is possible to set up an experiment where if the null hypothesis is false, you would see it. And a classic example of that, I'm not going to step on any toes here, but is the question, does God exist? Okay? That's a perfectly legitimate question, but it is not a scientific question or a scientific hypothesis, because there is no way in the metaphysical world or in the physical world to show that God exists. Why? Because our traditional concept of God is that he or she or it exists outside of the physical world. So God does not have to follow our little rules, but we do. So there's no way to show that God does not exist, because you design an experiment, nothing happens, and all you can say is, well, God didn't follow the rules. So that would be an example of a non-falsifiable and therefore non-scientific type of experiment. So moving to the next slide, let me clear this, clear the ink. Okay. So when we design an experiment to test a hypothesis, there are actually two hypotheses being pitted against each other even though one is typically the only one that is formally stated. You'll read about the null hypothesis, which is symbolized as H sub 0. And the null hypothesis is very simply that there is no effect of your IV, your independent variable, on your dV. Said another way, if you're comparing two groups on something, you are saying basically that the mean of the population, you are saying that the mean of group 1, where you drew your sample from, or population 1, is equal to mu of the other group. So you draw two samples and you're comparing them in some experiment, and what you're basically saying is that the mean where sample 1 was drawn is the same as the mean of sample 2. Okay, so that's the null hypothesis. The null hypothesis is always that there is no effect or no difference, or that the samples came from the same population. The other hypothesis that you are testing, the rival hypothesis, if you will, is the research hypothesis. And the research hypothesis is always that there is an effect of your IV on your dV. Effect of IV. Or said another way, if you're comparing two samples, you're saying that the mean of sample 1 is not equal to the mean where sample 2 was drawn. So those are the two hypotheses. Even though I may say, as the previous slide gave that example, that children of divorced parents have more behavioral problems than children from intact families. So which of those two hypotheses is that formulated as? The children of divorced parents have more behavioral problems than children from intact families. Well, hopefully you recognize that I am saying that divorced parents, the mean number of behavioral parents, the mean number of behavioral problems of children from divorced families is not equal to the mean number of behavioral problems from children from intact families. Therefore, that statement is the research hypothesis. It's implied that there is a null hypothesis, that there is no difference in the behavioral problems of children from divorced versus intact families. Okay, but we usually in research state the research hypothesis and imply the null. But here's an interesting point, and it's highlighted on the slides. All statistical tests are a direct test of the null hypothesis. Whenever we conduct our z-test, or later in the class we'll be doing t-tests and f-tests and r's and chi-squares and all of that, we are actually testing the null hypothesis. And if the null hypothesis is found to be untrue, or at least that we don't have any support for it, then we toss it out, and the only thing that's left is the research hypothesis. So the research hypothesis is usually supported by default once we eliminate or rule out the null hypothesis as a viable option. So that's kind of the philosophy of doing experiments. And this is not just behavioral sciences, this is all of science. We postulate a research hypothesis and then we test the null. If the null can't be supported, we throw it out and we're left with support for the research hypothesis. This is why I always say in classes, my research methods class and statistics classes, is that we never prove anything. So drop the word prove from your vocabulary. Why? Because we are only finding support for the research hypothesis. We cannot prove that every single instance in the entire population will always behave the way the research hypothesis states. We are only accepting support or finding support for a hypothesis. Now, that support may be replicated over and over and over again, and we have an extreme amount of confidence in it, but nonetheless, the word proven has a very specific meaning in science, much like the word random does. And technically speaking, we're not proving that an event always will occur. So just by way of example, if you're looking at the next slide, slide 17 of the lecture notes, I give you hypothesis practice. I list 5 research questions, and what I want you to do is just get practice. It's going to sound very repetitive, and don't overthink it. Practice writing a null and a research hypothesis. So I'll do the first one for you. The question is, do negative political ads help a candidate? So that's a valid research question. The research hypothesis would be that using negative political ads does help a candidate. In other words, the electability of a candidate is different from those using negative ads compared to those who do not. Okay, that would be the research hypothesis. The null hypothesis would be the opposite, that negative political ads do not help a candidate. That is, their electability does not change compared to another candidate who doesn't use negative ads. Okay, so that's the pattern. Always, 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 the null hypothesis is that there is no effect of your IV on your DV, and your research hypothesis is always, always, always that it does have an effect. Your IV does affect your DV. So just practice those next four, writing them down. Like I said, don't overthink it. Don't try and get fancy. Just say that there is an effect and then there is not effect for those two things. And when you're done, go on to the next slide where we discuss variables. Okay, the next concept are the different types of variables. Now, we talked about this way back at day one, so I just want to refresh your memory about the concepts of independent and dependent variables, and then add a couple of more concepts as well. So, the independent variable, or the IV, is always what is manipulated. Okay, it is how the groups are being defined and what the researcher is, quote, doing to the people participating in the study. So in the example that I give on the slides, if I'm interested in whether watching violent videos, violent movies causes children to be violent, then what I would do is bring children, a sample of children, into my laboratory. I would show half of them a movie that is generally considered to be non-violent, and then show my 5-year-olds a movie that we might all agree is quite violent, Reservoir Dogs. So what I'm manipulating then is the type of media or the amount of violence viewed by the children. That would be my independent variable. The other variable in experiment is the dependent variable. The dependent variable is always what the researcher is measuring. It's what's measured in the experiment. So once again, in my video experiment, I show one group of kids a non-violent movie, another group of kids a violent movie. That's my IV manipulation. And after showing them that video, I go out to the playground and I record what children are doing. So I'm going to sit there and then measure how much violence or how many instances of violence I see on the playground. And then I'll be comparing the level of violence observed in the group who saw the violent movie to the level of violence we saw in the nonviolent movie, for the kids who saw the nonviolent movie, and see if there's a difference. That is, if the two groups came from different populations, or if they differed just because of sampling error. If you remember, all samples have some degree of error. We don't expect the amount of violence in the two groups to be identical, even if the null hypothesis is true. If the research hypothesis is true, then we should see a pretty substantial amount of difference in the two groups. So that's the IV and the DV. However, there are still other variables that I discuss in the lecture notes. I'm going to go to a new image here. Okay, I mentioned a subject variable. This is the first time we've mentioned that. I said before, I previously defined the IV as what the researcher is manipulating. Now that's an important word. In science, if I'm manipulating something, that means that I, as the researcher, am the one who decides who gets what, who sees what movie. However, there's sometimes when I'm comparing something that I cannot manipulate. I am manipulating, or I'm comparing, for example, men versus women, or people who are depressed versus people who are not depressed, or people with blonde hair to people with brown hair, or green eyes to blue eyes, or people who are above average intelligence to people who are intelligent. The point is, those are things that I can't control. I can't decide who has brown hair or black hair. I can't compare who's right-handed or left-handed, or green eyes or brown eyes, or any of that. Those are subject variables when there's some characteristic of the participant that's being compared. And the reason we separate that out is if I can't manipulate it, there's a possibility that something other than what I'm studying is causing a difference between the groups. For example, if I wanted to look at, say, the emotion recognition between men and women. So I would find a group of men, I would find a group of women, and I would show them faces displaying different emotions and measure how quickly it took them to identify what emotion was being expressed. Now suppose that I find a difference. Suppose that I find that women have better or faster emotion recognition times than men. What's the reason for that? It may be the fact that men genetically have a different set of sex chromosomes than women. So it may be something at the biological level. Very possible. It could also simply be not the fact that they are men and women biologically, but it could be socialization. That women, at least in our culture, tend to be raised to be more nurturing, more caring, more in tune to other people's emotions than men are. And so we have the chromosome possibility, and we have socialization as a possibility. Those are two different research hypotheses or explanations for any finding. So the null hypothesis would be that there is no difference in the emotion recognition of men and women. The research hypothesis is there is a difference, but I can't control who is a male and who is a female. Therefore, I can't rule out all of these explanations for it. And if I can't, then I can't say that it's decidedly gender that caused the difference, even though that's what I'm comparing in my study, because it might just be socialization. And if we raise men to be more in tune to emotions of others, then the difference might erase or might disappear. So again, it's not the gender that's causing it, it's the socialization of the two groups that causes the difference. So that would be a subject variable. When the researchers are comparing some characteristic about the participants that the researcher cannot manipulate. And when we have experiments like that, it introduces a little bit of uncertainty about the research hypothesis. And the last variable discussed or mentioned is a control variable. And just real quickly, there are many factors that might influence the outcome of a study. And a control variable is something that a researcher doesn't manipulate, but they try to hold constant from one person to the next. For example, in my study about children and TV and violence, I might want to make age a control variable. That is, ensure that the two groups are equal in the age range of the kids, because you could argue that different age groups might exhibit more rough and tumble or violent behavior than other age groups. I might also want to make gender a control variable, because traditionally boys tend to be a little bit more aggressive than girls. And so if my group who saw the Bambi movie was made up primarily of girls, and the group who saw the Reservoir Dogs movie was primarily boys, I could see a difference, but it wouldn't necessarily be because of the movie. It might just be because of the gender makeup. So a control variable is something that the researcher holds constant across the groups purposely in order to rule out that variable as an explanation. So those are the four types of variables that I want you to be familiar with. The independent variable, that is what is manipulated. The dependent variable, what is measured. The subject variable, which is something that is compared like NIV but not manipulated. and a control variable, which is a variable that is held constant across groups to rule it out as an explanation for our findings. Which brings us then to the basics of our experimental design. We have in a simple basic experiment, we draw a random sample from a population, so that P stands for the population, and we draw a random sample from that population. So if the population was 5 million, we might draw 50 people from it, and that becomes our sample. With our sample, we then randomly assign people to one of two groups. We're going to assign them to the experimental group, and we're going to assign the other to a control group. And the difference is simply what level of the independent variable they get. The experimental group will get our manipulation. If we're studying the effect of violence on behavior, the experimental group is going to get the violence, the violent movie, whereas the control group will get the non-violent movie, because that's the default that we're comparing them to. If we're studying a drug, the experimental group will get the medication, and the control group will get the placebo, the sugar pill. At the end of the experiment, we then measure both groups on the dependent variable. And so what we're looking for is, because of random assignment and random selection, we are assuming, and it can be shown experimentally, that the groups are equal at the start. They are the same age, the same gender makeup, the same attitudes, etc., etc. But if they are different at the end of the experiment, then the only thing that could have caused that difference, since they started out the same, is what we did in the middle of it. So that's the philosophy behind experimental design. So here's an example of the design that we've been talking about the experiment that we've been talking about, watching different types of movies and its effect on violence. We are going to have two groups in that type of experiment. Now, so what's the independent variable? Well, hopefully you recognize that it is the amount of violence in the movie. Some watched a movie with violence, some watched a movie without. So don't confuse the IV, which is violence in a movie, with the levels of the independent variable. That's a weird looking E. There would be two levels. One, those who watched a violent movie, and two, who watched a non-violent movie. There's still one single independent variable that has two levels, violent and non-violent. Okay, so don't confuse the levels of the variable with the variable itself. The variable is like the umbrella term, violence, that, and then from there we have some or none, some versus none. Okay, and then we would say we had 25 kids in each group, so we're going to have an N of 25 and an N of 25, and we would get the average amount of violence exhibited in those two groups. That would be our measurement of the DV. And we're going to call that violent acts, the number of times that violent acts, the number of times a child shoved another or argued with another, or however we define violence for our experiment. So that simple design has one independent variable, the amount of violence in the movie. It has two levels, some violence or no violence, and a single dependent variable, the number of violent acts. And we are going to collect data on 25 individuals in each group and compare the average amount of violence in each sample. The null hypothesis is that there is no difference other than sampling error between the two groups, that movie type has no effect on violence. The research hypothesis is that the difference that we see is real. That is, they come from different populations with different levels of violence in them. So I want to now introduce a more complicated type of study, and that's called a factorial design. A factor is just a fancy word for an independent variable. And so when investigators don't limit themselves to a single IV, like the amount of violence in a movie, but instead might introduce 2 or 3 or 4 independent variables, we call that a factorial design. And so I've got a little diagram up here that suppose I'm still interested in comparing the amount of violence in a movie. But also I want to see if there's a difference between boys and girls in how they respond to violent and non-violent movies. So in this case, I have 2 IVs, right? We have movie violence as 1 IV, and that has 2 levels in this example, violent and non-violent. And then we also have gender. Now, technically speaking, if you were paying attention before, gender is actually a subject variable because I can't randomly assign the boys and the girls to be boys and girls, but it's nonetheless a part of my design. So I have 2 variables that I'm comparing: the amount of violence in the movie with 2 levels and gender with 2 levels. And that's a factorial design. And we'll be talking about more complex analyses like that a little bit later in the semester. And about the last thing I think I'm going to be able to fit into this video is the different, another variation of designs, and that is where we compare a between groups design to a within groups design. Now, a between groups design is where the samples are completely different. They are independent of one another. So another term for that is an independent groups design. So we might have a group of 25 children who watch a non-violent movie and compare that to a completely different set of 25 children who watch the other type of movie. That would be a between groups design. In a within groups design, we have a group of 25 children who first, that's a 25, who first watch a violent movie and then they watch, I'm going to say they watch a violent, and then they watch a non-violent movie. Same 25, okay? Same individuals participated in both levels of the independent variable. There are advantages and disadvantages of both types of design, but you can read about those in your textbook, but I wanted to try and drive home the definition of them. You've got a between groups design if they are 2 separate groups of individuals, and a within groups design if the same individuals participate in all levels of the independent variable. So I think I'm going to stop this video right here, and then I've got one more part to this series where we're going to apply research design, collect some data, and see how statistics can help us answer the question about whether the null hypothesis is in play or not, and if not, then how we decide what the other hypothesis, whether the other hypothesis is supported. So let's watch the other video now.